Hello, ladies and gentlemen. Welcome to Math 20-3, Chapter 1, Section 5, Rate of Change. Now, review before we move on. Jessica needs to get water to a cabin from a reservoir 750 meters away. She uses PVC pipe with a 0.8 degree slope to transport the water to a tank at her cabin. The intake of the tank at the cabin is 1.5 meters above the ground. At what height above the ground must the other end of the pipe enter the reservoir? So I'm drawing a picture here. And note, some of you, 750 meters is on the hypotenuse. It's the base of a right angle triangle here. I apologize, you have an older version of this. But I'm trying to use safe paper, so anyway. So, at what height? H. Now you're going, okay, where have we seen this before? Well, I go back to the last lesson. Yes, tan of theta, opposite over adjacent, which is rise over run. It's also the percent grade, but tan of theta is rise over run, something we learned last class. Tan of theta. Of course, we have a lot of space here, so I'm going to move this up here. So this is tan 0.8 degrees equals the rise, h over my run, 750 meters. So it's h divided by 750. How do I get rid of divide by 750? I multiply both sides by 750 meters. So, grab your calculator. And that one has work. 0.8. Now, calculation class, you got to go 0.8 times tan times 750. H is 10.47, which is 10.5 meters. All right? Now, so far so good? Good. Now, what's the trick? The pipe is 1.5 meters up, so there's 1.5 meters here. So you have to add 1.5 meters for a total pipe of 12 meters up. I know I'm sneaky, I don't like that, but tan is rise over run. That's what you need to remember. Okay? Alright, now, moving on, and if you have an older version of this, this was labeled 1.3 rate of change. It's actually 1.5. Now, imagine that you work for a company that pays you $10 an hour. Fortunately, minimum wage is higher, but I'm keeping 10 to make the math simple. If you work a certain number of hours, the amount that you will get paid will increase. When your payment increases, will increase. When your payment increases according to the number of hours you work, this is called rate of change. So increase in rate of change. The rate of change is the rate at which one variable changes compared to another variable. So throw in some fancy math ways in here. Rate of change. Now, here we go. Hours worked, amount paid. And here's why I get it at $10 an hour to keep the math simple. 5 hours worked is $50 paid. 10 hours worked is $100 paid. And we can graph that here. See hours worked on the x-axis, amount paid on the y-axis. Okay? Now, when the relationship between the variables is constant, it has a linear relationship. Graph of a linear relationship is a straight line. Linear line, notice it's straight. The graph is straight. Linear relationship is a fancy word of mine. Right, now, some vocab. In a rate of change, the change of one variable depends on the change, depends. In a rate of change, the change of one variable depends on the change in another. For example, how much you are paid paid depends on how many hours you work. Therefore, one variable is known as the dependent variable, and the other is the independent variable. So you follow carefully. In our case, the dependent variable is the amount you're paid, and the independent variable is the amount that you work. So, you might want to pause the recording here and make a note on your blue formula sheet, the cheat sheets, dependent versus independent variable. Okay? Because I will throw a couple questions on back to you on this. Dependent variable is the amount you are paid. The independent variable is the amount you work. Now note here, independent is the one you can't control so much. It's the one you, sorry, let me phrase that. Independent variable is the one you have no control over. It's how much you work. So the boss says, you go home today, or I need you to work extra hours, you can't control that. So that's independent of your control. The dependent variable depends on the independent. How much you get paid depends on how many hours you work. I know, confusing. That's why you should pause the recording, come up with a better definition, and write it out so that you remember. Okay, so when you're done, we'll go on to the next page. All right, moving on. When we graph a rate of change, the dependent variable will be on the y-axis, and the independent variable will be on the x-axis. Most often, the independent variable will be time. So, independent variable on the x-axis, that's usually time. So, hours worked is independent, except the boss says go home early, or you need to work extra time, you have no control over that. The dependent variable, the amount you paid, depends on how many hours you work. Now, in order to find the rate of change, you need to see the relationship between the changes in the independent and dependent variables. You need to see the changes in the independent and dependent variables. Here, we can see that the change in the hours worked, independent, is the run. The change in the amount paid, dependent, is the rise. So I will throw rise and run at you again. Surprise! So, hours worked is independent, the amount paid is dependent. Now, in other words, the rate of change is also the slope of the graph. The rate of change is the slope of a graph. What were we paid? $10 an hour. What do you want to bet the slope of this graph is? Actually, that's not bad. Let's prove it. So, amount paid versus hours worked. The rate of change is the slope of the graph, as we just said. What is the slope of this relationship? Well, slope is rise over run. So, what I've done is I arbitrarily chose 2 points. Right here, right here. I can choose any 2 points on a straight line. This is my rise. And this is my run. Now, I want to point out, I was drawing them like this. Oh, you fudge nut. Again. Don't be. That's why. Alright. So, let's put in the rise over here. And run up here. What I should be doing. Unfortunately, that requires me remembering stuff like that. Anyway, so rise is what? Going from 100 to $200. So what is 200 minus 100? $100. What's the run? Well, I'm going from 10 hours to 20 hours, so that's 20 minus 10, that's 10 hours. So what's my slope here? Well, graph calculator. What is 100 divided by 10? Well, $10 per hour. I hope. Which is in line with our original statement. For each hour you work, you get $10. So the slope is your pay. Yeah? Now, so far so good. I'm going to pause the recording here, and once you review this, then we're going to go on and start the example questions. So if you have any questions, watch the video again or ask me for help. Okay.
look.